So in Module 4, what we're going to do is wrap up Piaget's cognitive development theory, at least as far as the traditional 4 stages that he proposed. And so in Module 4, we're going to review concrete operation, which is stage 3, and formal operations. So what we see in concrete operations is that this happens roughly between the ages of 7 to 11 years old. And it involves mastering the logical operations that were missing in the pre-operational stage. So everything I was talking about in Module 3, where I said, oh, these pre-operational children can't do it, now they can. So just to quickly reorient you, that means they're able to decenter, meaning they're focusing on more than one dimension of a problem at a time. They can apply reversibility because they can engage in transformational thought, which is the video, as opposed to static thought. They have the concept of class inclusion, which is higher order thinking for ways of classifying. Actually, this is one of my neuropsych tests, gets into that sort of issue of higher order thought with a kind of classic kind of construct there. Some other things that we see in the concrete operational stage that they are able to do once they reach this concrete operations or in the process through the concrete operational stage is something called seriation. Seriation enables a child to arrange items mentally along a quantifiable dimension, something like length or weight, and they can do this mentally. So if I had, for example, a whole slew of pencils or crayons of different lengths, and I threw them on the table there, and I said, I want you to put these in order mentally. What you would begin to see if you were a pre-operational child is they could do it, but they would take a crayon, take another crayon, measure it, and put one aside. Take another crayon, measure it, put it aside. And they'll eventually get in order of height, more than likely. But a child in concrete operation stage should be able to mentally go, okay, these are the taller ones, these are the shorter ones, and be able to do it much more efficiently. And that is because they're able to do things according to seriation. Another skill that they pick up is transitivity. And transitivity describes the necessary relationships among elements in a series. So the example here, it's a classic LSAT kind of problem, logic problem. So it would be if John is taller than Mark and Mark is taller than Sam, who is taller, John or Sam? So a pre-operational child would really rely upon their perception rather than understanding size relationships that you would see in this problem, and where you're mentally figuring out what the relationship is between these various ones. And therefore, I can then answer that question correctly. Of course, the ones on the LSAT are going to be a little bit more difficult for any of you future lawyers out there. Okay, so that's transitivity. Now, one of the big hallmarks then is really overcoming a lot of that egocentrism that was so evident in pre-operational stage in the concrete operation. So that involves things like perspective taking and other things like that. They're also going to master at this stage a lot more of mathematical operations because that also requires a lot more advanced thinking. So think about division, multiplication. These things are a lot harder to use literal apples or concrete examples that you're going to do with pre-operational children in regards to learning things like addition and subtraction. Okay, so a lot's going on in concrete operational stage, even though we covered most of that under pre-operational stage in Module 3. So what we're going to do next is move on to the final phase, and that is formal operational thought, occurring at around age 11 or later. Really what it lines up to is when an individual goes through puberty, and what we talked about in a couple chapters ago with this whole brain growth spurt that happens along with puberty. And I mentioned at that time, that is when abstract thought comes. That's when this formal operational thinking starts to kick in. And what you begin to see is that adolescents begin to be able to mentally juggle ideas back and forth and think logically in an abstract manner. And they get really good at predicting at what might come in the future. And that's because they can think beyond the here and now, the what I can have in my hands, what I can sense and see. and think about more theoretical aspects of things. And this is what eventually leads to adult thinking once you've gone through some formal operational stage. And that's where most adults are going to be, at least at their topmost. Most of us aren't at formal operational thinking for everything in our day-to-day lives, because quite frankly, it's hard thinking. And so most of us operate in a concrete operational world because that's the easy way to do it. But when we are called upon or we need to show our expertise, a lot of times we switch it into high gear, and that's our formal operational thought. Now, one of those high gear skills that we're able to do is hypothetical deductive reasoning. And that's reasoning from a general idea to a specific implementation. So if you know the theory of something, then you're able to actually then do that thing. And the classic example here is what's called the pendulum problem. And so the pendulum problem, which I believe I have on the next slide, but basically it looks at what dictates how fast a pendulum goes. Is it the length of the string? Is it the weight at the end of the pendulum? Is it how far back I take it? Or is it how much I push it to get it going? Okay, and then you have to think about that. And how do you solve that problem? Well, the way that a hypothetical deductive reasoning does is engaging in the scientific method, which is isolating each variable, trying out those variables with everything else isolated, and therefore I can come up with a conclusion. Whereas a concrete operational thinker might try two or three variables at the same time. So even when there's a change, we can't conclude what caused that change. And so they don't engage in that kind of more deductive type of reasoning that is so important, that, you know, in this particular stage and in life in general, to be able to think at that level. And so, by the way, the answer is the length is what dictates how fast a pendulum goes, just in case you were wondering. So the big next task that really sets this stage apart from all the others is abstract thinking. So an abstract concept allows us to do things like define words. And so what I ask, what is freedom? What is freedom? And for a younger child, freedom, they will say something like the flag. The flag is freedom. And while it's a symbol of freedom, the reason a concrete operational, pre-operational child would say that is that it is a concrete thing I can point to and say, that flag, that is freedom. But that's not really what freedom is. It's an idea. It's an idea to be able to do what you want to do, not to be told by others, not to be hemmed in. And so what you see is as you start moving from elementary to middle school, you begin to do this abstract thinking. You're able to define what words mean, and you're going to be able to succeed much better than you would otherwise. So can't stress this enough. You're able to understand literature at a much deeper level because there's symbols behind or reading between the lines. That's all abstract thinking. Or thinking why Marcy did this to you and how you might get her back and how she's going to respond. That's all also abstract thinking. And you see that in a lot of middle schools. Particular cliques can get into these little battles because of these anticipations of what somebody's going to do, how they're going to react, and the manipulation that might be involved with it. So, you know, use your abstract thinking skills for good, not evil. Systematic and scientific thinking, that's what I was kind of going back to with that hypothetical deductive reasoning. And really the ability to do something called decontextualize. So decontextualize is separating knowledge and beliefs that you have from maybe the task at hand. And one of the examples I would have is if you ever have had to do a reverse mirror task. So one of the things they like to do in some scientific studies is to have you try to do a maze, but do it in a mirror. Okay, so you can't rely on your previous knowledge to successfully pass that task because every time I move to the right in the mirror, I'm actually moving to the left. And so I have to mentally reverse myself or decontextualize to be able to answer things correctly. So what we are able to decontextualize, we increase the likelihood of using our reasoning to analyze a problem logically rather than just relying on our intuition or faulty existing knowledge. And that's how we get to the real answers, the things that are going to serve us well in our society and be able to come up with the right answers. Now, one of the things about formal operational thought is that age and education are going to play a role in this. So you're not going to get to formal or infinitely obscure amount of children are ever going to get to formal operation before age 10. There will be a few gifted that can probably engage in some of it, but by and large, you don't get there. You have some maturational influence. So going back to those major themes that we were talking about, kind of maturation versus environment, maturation certainly plays a role, but it is not enough. You can't just simply wait until a child turns 11, 12 years old and then they kick in formal operational thought. They have to have an education. So when I referred to scientific thinking, not everyone around the world gets exposed to scientific thinking. That's a very westernized way of thinking. So if I'm in a more traditional type culture where we're kind of hunter-gatherers and the hunters have to go hunt down, say, an antelope, I can use formal operational thought characteristics, but not the way that Piaget defined them, because I haven't had that type of education. My society hasn't valued that type of education. It has valued another type that fits the way that we exist in the world in the particular culture. And we'll get more into that in the next module. Here is the pendulum problem that I was referring to earlier. So in our next module, we're going to talk about a man named Elkind, who came up with some correlates of formal operational thought. They aren't Piaget's theory, but they certainly apply and illustrate some of the issues that one is undergoing in formal operational thought. And then some Piaget scholars weren't satisfied with formal operational thinking being the end of thinking. Because once again, kind of like some of the other theorists we were talking about in chapter 2, what a bummer to enter the last stage of cognitive development really in your early teens when, frankly, you're going to live many, many more decades. And so they have something called post-formal thought. So we'll get into both of those starting in module 5, our next module. So stay tuned.